So 5.3 inverse functions. Again, total review of Algebra 2 and pre-calc of what an inverse function is. So remember, inverse functions interchange the domain and range. Correct? The x's of one or the y's of the other, the y's of one or the x of the other. Okay, so how to verify them? We have to do f of g. Oh, my underline didn't work. We have to do f of g of x, and it has to equal x. And you have to do g of f of x, and it has to equal x. Remember doing that?
Yeah.
Okay. So this to the negative 1 power, f to the negative 1 power is how you note inverse. You don't say f to the negative 1, you say f inverse or g inverse. Got it? So when you're talking about a function, it's not like the reciprocal, because that would be a negative exponent, correct? So this is the x's or the domain, and this is the y's. So the x's of the x's of your parent function are the y's of your inverse function. The y's, that's what it is. I don't know how much you guys are writing.
I'm just writing that picture.
Okay. Domain and range physically do this, right?
Yeah.
Okay, good. Okay, so show that the functions are inverses of each other. So if they're inverses of each other, it's going to equal x, correct? So I'm going to do f of g of x. So this whole thing replaces what? That x, right?
Yeah.
So 2, the cube root cubed minus 1. And all this stuff goes into that cube root, correct? That is very sloppy. I must have had too much coffee this morning. Sorry. I feel like I'm everywhere. Okay, so when I cube a cube root, I get what?
1/3.
Well, I'm cubing a cube root, so they undo each other, don't they?
Yeah.
So I just get the radican. So x plus 1 over 2 minus 1. Then what happens?
You want to say distribute?
No.
Oh, no. 2 minus 1.
Don't the 2's reduce?
Oh, 2 reduce, yeah.
And I have x plus 1 minus 1. So I get what? X. So that one worked. And if it says show that, is it going to work?
Yeah.
Yeah. Now, if it says determine, it could not work. But if it says show that, it better work. So now I'm going to do g of f of x. Am I going too fast?
No.
Okay. So this whole thing is going to go in for that x now, correct?
Yes.
So I'm going to have the cube root of x, which will be 2x cubed minus 1 plus 1 all over 2. And I like to put mine in parentheses so I know what I put in. So there's nothing to distribute, so the parentheses really aren't there, but I have a minus 1, a plus 1, so that becomes 0. And the 2 and the 2 can reduce. So I now have a big mess on my papers, but I have the cube root of x cubed, which is what? X. Now, you guys always try to do one of these things. Can I get away with doing one of them?
No.
You have to do what?
Both.
Both. You have to do both. And if the variable was n, they would equal n. If the variable was I, they'd equal I. Remember doing this?
Yeah.
Tell me when you guys are good. Okay. So also we've talked about in the past is how they reflect, the two graphs reflect over the XY line. Yes?
Yeah.
Okay. So if any question ever asks you, what does the inverse function look like compared to this? You say reflects over y equals x. That's what it is, isn't it? Okay. So now it says show that the function, oh, we just did that. Never mind. That was the same slide, but there's the graph. Do they reflect over that line? Yep. Just said that again. Okay. Finding an inverse function. It has to be 1-to-1, meaning every x has one y and every y has one x. It means it passes both the vertical line test and the horizontal line test. Remember doing those things?
Yeah.
And if f is strictly monotonic on its entire domain, then it is 1-to-1 and therefore has an inverse function. Now I want to stress this. Every equation has an inverse. Not every equation has an inverse function. Does that make sense?
Yeah.
So if I gave you this graph, okay, is it 1-to-1? Does it pass the vertical line test? Does that graph pass the vertical line test? Does it hit the once? Yes. So it's a function, yes? Does it pass the horizontal line test? Does it?
No.
Does
Yeah,
it? No. So it has an inverse, but is its inverse a function? No. Because when I reflect this, oh gosh, it's not going to pass the what? The vertical line test. Make sense?
Yeah.
So if it is 1-to-1, it has an inverse function. And that's the word that sometimes people forget to say. Because they'll say, well, the book says not everything has an inverse. No, everything has an inverse. Does everything have an inverse function?
No.
No. Got it? Monotonic just means mono, like one change. Just one. Okay. Which of these has an inverse function? And again, this is the words from the book. Which function has an inverse? Well, they both have inverses. It's which one of those has an inverse function. Does that make sense? Okay, so this is x cubed, and an x cubed, the parent function to x cubed looks like that. And let me there. Does that pass the vertical line test? Yes. Because again, vertical line test, does it hit it once?
Yes.
Yes. Does it pass the horizontal line test? Now, this is constantly changing just a little bit. This is changing just a little bit, not a lot. It's not horizontal, so would it pass it? The two ends, these are not horizontal. They are changing just a very slow rate. So it would pass the horizontal line test. Okay? Both of them are cubic functions. So let's check what their inverses would be. Okay, so how do you think we find an inverse? Do anybody remember? What two things interchange places?
The X.
And the
Y.
y. So we make x's y's, y's x's.
Oh, yeah.
So it's going to be x equals y cubed plus y minus 1.
Yes.
And we got to solve this for
X.
y.
Y.
Okay. So how do you think we're going to go about that?
Well, can we reduce? No.
Do you think we should move the 1 over here?
Yeah.
Okay. So I have x minus 1. Well, that's not going to work. Because I got to factor it, don't I? Let's see. Well, okay, let's try it. So I got x minus 1 equals y cubed plus y. I'm assuming I'd factor out a y, wouldn't I? So I get y squared plus 1. Well, this would be well, I can add back over the 1. Now, the reason I can add back over the 1 is that now I can set it equal to what? 0?
Yeah.
So then it'd be negative 1 equals y squared plus 1. So then y equals negative 1. And then y squared equals, we'd have negative 1 minus 1, because I'd subtract over the 1. Am I skipping too many steps?
Yeah.
Okay, you know how I got y equals negative 1, yes?
Yeah.
Because that. So then I have y squared plus 1 equals negative 1. So that'd be y squared equals negative 2.
Yep.
And you'd have to take square root of it, but it's a negative number, so is that real?
No.
No. So it's imaginary. Okay. So I think this one has an inverse function because this is imaginary, right?
Yeah.
So it's gonna pass, and this is linear. So is it gonna pass that test? You don't think so?
Yes.
Okay, we're gonna graph it in a second. You wanna graph it?
Yeah.
Okay, pull out your calculators. I wonder if I have. Ah. There. Okay, so what's this look like? What's the parent? Because the parent function is what I can graph, right? Because it's y equals.
Yeah.
So put the original function in your calculator. So y equals x cubed. Oops. X cubed plus x minus 1.
Yeah.
And zoom 6 it. Okay. So this graph looks like this. Does that pass the vertical line test? Yes. Does it pass the horizontal line test? So does it have an inverse function? Okay. So since we have it, this just changes it to a what? Plus 1?
Yeah.
Now, how is that going to change our math over here before we graph it? Oh, it's a minus x too, isn't it? So that we had x equals y cubed minus y plus 1. So if we follow what we did before,
So on B, are we? Oh, yeah. Never mind. I see what it is.
so we subtract, and so we'd have y and then y squared minus 1.
Yeah.
Okay. And so then if I set it equal to 0 then, so y would equal negative 1.
So it's just.
This should have been positive 1 over here.
On the first one, shouldn't it
That should be positive 1, shouldn't it?
Yeah.
Yep. So it only changed this to positive 1. Sorry. And over here, though, that's going to give me y squared equals 0, isn't it?
Yeah.
Because you're going to subtract 1 and then add 1. So that would give you y equals plus or minus 0. Now, plus or minus 0 is how many numbers? Just one number, isn't it? Now, if that was plus or minus 2, that'd be how many numbers? If it was y equals plus or minus 2. How many? It'd be what? 2. So would that pass the horizontal line test? No. But is this only actually one number? Yes. So on this one, the graph would look something like if x was 0, y would be negative 2 and 2. That's what that one would look like, yes? But this one, what happens when it's a double 0, guys? What happens to it? What happens to an equation when it's a double 0? A graph, excuse me. Yeah, but when a graph has a double 0, you remember me bouncing off the door?
Oh, it's the...
It bounces.
Yeah.
Yes. So if it bounces, there's going to have, like, it's going to hit, like, 0. And, oops. I always have it on the eraser when it's going to do something like this, isn't it? Somewhere in there. Because it's a what? It's a double. So is that going to pass the horizontal?
No.
No. Why did we have this issue? Because we had what?
Have the double zeros.
We have the double 0, or you have the two values, because every x has one y and every y has one x. And how many x's are here? 2. But this has one x, but it's a double, so it bounces. Am I making sense where I'm going? So the first one we were good because this is imaginary. It didn't cause me an issue. But over here, is this imaginary? No. So is it going to happen when I have an odd root? Like 3, 5, 7? No. What's going to happen when I have a 2, 4, and a 6? An even root. So when I have an even root in my inverse, is it going to be 1 to 1 then?
No.
No, because it's not going to pass that horizontal. So this one might look like, I know it doesn't, it might look like this. That would definitely not pass the horizontal, would it?
No.
Now, on these, I want you to do them algebraically and see if you can figure it out, and then check it where? Your calculator. I want you to see it. Got it? If you see the parent function, because if you put the second one, go ahead and put that second one in your calculator. All it does is change the minus and the plus.
So they're mine.
Mm-hmm.
So the error, mine by minus 10.
I think you maybe did it wrong.
Oh, yeah, I do.
And like, I think you did it wrong. Now, can you see that that's not 1 to 1 on that picture?
Mine kind of stays the same.
No, but you have this. Doesn't it go like... It should look like something like this.
Yeah, it doesn't. Yeah, I see what you're saying.
Doesn't yours look like that?
Yeah.
Okay, but can you see that's not 1 to 1?
Yeah.
Does it pass the vertical line test? Yes,
But it doesn't.
but it doesn't pass the horizontal line test. That's what I'm getting at. Okay? So now your last slide is finding the inverse. So if we... Here, we were finding the inverse right here. So we interchanged the x and y and then solved for y.
Yeah.
Okay, so guidelines for finding the inverse. This is on one of the pages in the book, and I don't have the page written there. Sorry. You interchange the x and the y and solve for y. That's what you do. And then verify. But you know that. Okay, so this is y equals, correct?
Yep.
So we're going to make it x equals the square root of 2y minus 3. Okay, so I'm going to solve this for y. So what do I have to clear first?
Square root.
the square root. So how do you undo a square root? Square it. So x squared equals 2y minus 3.
Yep.
And then?
Well,
You're solving for what again?
y, so we need to bring the y out.
So, well,
I don't know.
you guys are used to solving for x. That's why I'm going to keep asking you, what are you solving for? So, what do you have to move first? 2y minus 3. What do I have to move first? The 3, and then do what with the 2? Divide. So, f inverse of x equals x squared plus 3 over 2. 2.
The y.
You got to keep reminding yourself. This is actually y equals, yes?
Yes.
Okay, if that will help you. You got to keep reminding yourself you're solving for y because we're used to solving for x. Now, how would I verify this? I would do f inverse of x. So I'd plug in for that x, wouldn't I?
Yeah.
So I'd have the square root of 2 times x squared plus 3 over 2 minus 3. Okay, how's that going to... Because if they're inverses, should they fall apart really easily?
Yes.
Yes. So what would I do first reducing that?
The 2's.
The 2's reduce to 1.
The 3's.
The 3's would go to 0.
Square the square root.
And square root the square.
Yeah, square root the square.
And you get what? X. So let's do f inverse of f of x. Okay, so this whole thing in for that x. Yes?
Yeah.
So I have the square root of 2x minus 3 squared plus 3 over 2. I'm going to go sideways because I ran out of... Well, you square root, you get what? The radicand?
Yep.
So 2x minus 3 plus 3 over 2?
Yep. The 3's are turned to 0.
The 3's turn to 0.
And then the 2's reduced.
The 2's reduced to 1. And you're down to
X.
x. So did we do it right?
Yep.
There you go. That's it. You should all be having flashbacks, correct?
Yep.
Okay, that's all you're doing today. Verifying, finding.
Okay.
Got it? You don't have, it's not a very long assignment. It's like, it looks long, but it's not. Like, it's weird. One section is verify, one section is find. And do you guys see on 39 through 49, you're only supposed to do A and B? Do you see that? Like, does that make sense? There's like an A, B, C, D.
Yeah.
I want you to do A and D.
A and B.
I think A is find it and D is verify it,
Okay.
if I'm not mistaken. One of them's like graph. You know what the graphs should look like. If you want to graph them, you can. But I'm only looking for A and D.